Hello everyone. So my name is Dr. Lim. So we are going to continue. Our next topic is about roofs and coverings. So this is the content of this topic, introduction, and then we're going to look on general principles of design, choice of roof types, and you have to know basic roof forms and pitch roof constructions, gambrel or mansard roof constructions, and then you are going to learn about flat roof constructions, roof insulations, roof coverings, dormer windows, and then rainwater downpipes, RWDP, and the last one is timber roof preservation. So the first question is, what is roof? What do you know about roof? Because we are normally went in and went out in from a building, go inside any shopping malls, residentials, and everything. Have you noticed roof? Yes, you do, right? But what is roof actually? So in simple terms, a roof is the top covering of a building, okay, that protects it from weather elements like rain, snow, sunlight, and also wind. It's like a protective lid over your house and keeping you and your belongings safe and dry inside. So this roof can be made of various materials such as shingles, tiles, metal, or thatch. So depending on the climate and design preference. So the question is, what is roof? That I have explained before can be defined as the upper covering of the building and fully exposed to rain, snow, wind, sun, and general atmosphere. So these are the general principles of design that you have to remember. First, roof to provide resistance to excessive heat loss, at least to the standards set out by UBBL. UBBL is Universal Building by Law. So you have to know that this roof must have resistance to excessive heat loss. Okay. Second, roof structures to provide resistance to failure due to overstressing. So it must be able to support on self-weight, wind loads, and imposed loads such as snow. So you have to know that this roof is the top covering of the building. So normally roof will be subject to any loads. For example, like wind loads. For our country, we don't have snow, but different country they have snow. So snow pretty much heavy. Okay, so this roof structure must have adequate strength, okay, to prevent failure to overstressing. And then roof coverings, which is to provide adequate weather exclusions, okay, have reasonable durability and be aesthetically acceptable. So of course, this roof is being built outside the building. First, must provide adequate weather exclusion, which is heavy rains, uh, heat, okay, direct heat from sunlight, snow. So must provide adequate weather exclusion, and then must be durable and also aesthetically acceptable. Of course, we want that roof to be attractive. Okay, for example, like if that building is for um, to attract tourists. Okay, so sometimes roof can be one of the attractions, okay, despite from what it's supposed to be. Next, roof lights is to provide natural daylight, okay, through the roof. So some of the design principles of roof must provide natural daylight. Okay. Some of the roof does not provide. So we have to look what the requirements of that building and the roof itself. Okay, for example, that if the roof have attics room or have some spaces on that roof, okay, we have to provide some lights, not lights in terms of lamp, provide lamp, electrical light things and so on, but natural lights means that we have to provide windows, okay, on that roof. But again, this is depends on the functions of that spaces under that roof. Sometimes if our building have attics, right? Attics, so we have to provide roof, okay, sorry, provide natural daylights. And then roof is to provide adequate drainage of roof coverings. Okay, you know that roof is the top part of the building. So to provide drainage of the roof covering is very important. When there is heavy rain, how this rain being channeled from the roof to the ground. So that's why we have to provide the drainage of the roof coverings. Roof is to provide required degree of sound insulation and also to protect what happening inside the building, okay, to protect from the sound pollution. So we have to provide some sound insulation. Okay. Next, roof to be accessible for maintenance. Yes, this is very important. Okay, roof maintenance is very crucial because if anything happens on the roof, if there is a leakage, if the roof covering needs to be replaced, so we have to provide the access route for a maintenance works. Okay, so these all the 7 general principles can be drawn into this diagram. Okay, so if in the test or final ask you to sketch and elaborate general principles of design of the roof, so I expect you to can draw this diagram and also label each of the component here. Okay, first, like this one, provide natural daylight through the roof is required. So the word is if required, as I said before. Okay, roof covering to provide adequate weather exclusion, have reasonable durability. Roof to provide resistance to excessive heat loss. Okay, and then must set according to the standard. And then roof structure to provide resistance. So roof, this is roof tiles or coverings, and this is the structures of the roof. So the roof structure must provide resistance to failure due to overstressing, and then provide adequate drainage for roof covering. So this is a roof covering. So how we provide the drainage to channel down the heavy rains. And then roof to provide the required degree of sound insulation. So inside underneath this roof, we have to provide some sound insulation for the roof. And then roof has to be accessible for maintenance. Okay. Choice for roof types. There is a wide range of type available and the choice may be influenced by the number of factors. First, size and shape of the building. So how we have to determine the size or types of roof by looking at the size and shape of the building. Okay, what kind of the building, and then what size of the building, the shape of the building. So we can decide the choices of roof types. And then appearance. So perhaps that this roof could be one of the main attraction for that area, for that building. So we have to consider the appearance of the roof. And then economics. Okay, how much cost or value for this building, including the roof structures itself. So if we have extra cost, extra budget to allocate for the roof to be more futuristic or more sustainable, any requirements that required, okay, by the client for that roof. So it's depend on the budget. And then other considerations is with services and maintenance. So this one has to be one of the important things to consider when we decide to choose any types of roof. Okay. Basic roof form. So what are the basic roof forms? Roof can be classified as either flat, which is pitched from 0 to 10 degrees. So if you see, or you cannot see any building that have a roof, that is most probably a flat roof. Okay, so the pitch for a flat roof, even though that's a flat, it is called as flat, but it must have a little bit of pitch, okay, 10 to 0 to 10 degrees, because this is very important for the rains to fall down. Okay. And then we have second types of roof form is pitch roof, which is any roof that the degrees is more than 10 degree. So, and then roof pitches over 70 degrees are classified as what? If you saw any roof that the pitch is over than 70 degrees, we didn't call it as a roof, but it is under the classifications of wall. And then roof can be designed in many different forms and in combination. Okay, we are not going to use only one type of the roof, but we can also design in many different forms, and we can combine many of the shape of the roofs. And there is so many innovative roof right now in a modern construction right now. So what we are going to learn for this topic is only the basic roof types. Okay, this is an example of roof forms, the flat roof. So this one you can refer to the page 266 to look details on the components of flat roof. So this is, we call it parapet, which is the edges of the building that connected with the roof. This is parapet. Sometimes the parapet is lower and sometimes it's higher. Okay. On top of the parapet, we have coping. Okay. And then inside here is the wall. This is the wall, basically the wall. Okay. To form as a parapet. And then this is the flat roof, and flat roof must have a little bit of degrees to provide some fall here, okay, to make sure that when there is a raining, water from the rains will fall down to this. What is this? This is a RWDP. Okay, rainwater pipe. See, this one will convey and discharge the rainwaters, okay, to the drain. Okay, and if you can see the part that we connected this drainage here, we call it fascia. Okay, if you have drainage that connected, okay, to this surface here, we call it fascia. If there is no anything here, we call it as a verge, the non-drained edge for a roof. So this is the closing member of a roof's construction. Okay, this one is a verge. The closed area here is fascia. Okay, and then we have this one small curb. Okay, to make sure that the water does not fall down from different direction. We wanted the water to go down to this drainage. Okay, so roof slope towards drainage edge to if angle and slope governed by the type of roof covering. So this one must have a little bit of slopes. Okay, and top here, lower down here, we call it as a skirting. Okay, so next one is basic roof form. We have lean to roof, mono pitch, gable end, hip end, mansard or gambrel, and then the combinations of basic roof. Okay, this is the diagram of basic roof forms. First, lean to roof. So you can see these are walls, and then this roof is lean. Okay, lean to the wall. So this is lean to roof, we call it. Okay, and normally lean to roof is provided as for garage. Okay, that some extra spaces connected to the building. And then we have mono pitch roof, which is mono is one. Okay, only one sided of the roof. So this one is the mono pitch. And gable end roof. So this is the gable end roof. Okay, this is the normal roof that you always draw uh, the shape of the roof, right? So this is, we call it gable end roof. And then another one is hip end, which is we have some shape at both of the ends of this roof. We call it hip end roof. The mansard or gambrel roof, okay, look here. So there is some extra space you can see inside this roof. So normally when we choose the forms of mansard or gambrel roof forms, we also provide some dormer windows. Okay, and normally this is the area for attics or another room. And then basic combinations of basic form. So we can combine many of the forms of roof and then to provide dormer window for the roof. This is the diagrams of the components of the roof, the basic component that you have to remember and to understand. Alright, this is the structures of the roof. Structure of the roof without the covering. We do not put on the covering yet. So this is the inside underneath the roof. Okay, the structures of the roof. This is wall. So normally the components that connected from wall to wall, we call it ceiling joist or rafter tie. Okay, rafter tie. And the one that has slope or put in like to shape the shape of the building here, okay, this one we call it F rafter. Okay, this one is rafter. Okay, so to connect between both rafter and the name of this component is collar tie. So you have to remember this one. Okay, Okay, this is another diagram. Okay, so you can see this one is the lower part is, okay, this one is wall plate first. Okay, this is wall, and then we put on the wall plate, okay, on top of each wall. Okay, and then from the wall plate we lay down the ceiling joist, this one, ceiling joist. Okay, this is not short, this is from here connected to connected to the other sides of wall. Okay, this ceiling joist same goes to here. This one will be connected through to the other sides of the wall. And then this one is the rafter. Okay, and the one that on top, okay, here on top of the pitch of the roof is rafter. This one, top of it, call it rafter. Okay, and this is the components per length is the components that connected all the rafter here. Okay, all the common rafters, right? And the other side here is hip rafter. All right, next. Okay, in pitch roof types, we have several types in pitch roof. Okay, one of it is single roof. Single roof where rafters are supported at the ends only. Okay, so I hope that you still remember the previous diagram. Where is the rafter? So it says that single roof, the rafter are supported at the ends only. The simplest form is the lean-to roof or pan roof, where one wall is carried up to a higher level at the other, suitable for outbuilding or garage or not more than 2.5 meters span. So it says that single roof is very suitable for lean-to roof. So still remember the diagram of lean-to roof, whereby we have one side of the roof that lean to a wall. So that one is suitable for garage. And then the span, okay, not more than 2.5 meter span. Couple roof consists of rafters supported by ridge board and wall plates, suitable for roof span not exceeding 3 meters. So next one, we have couple roof. Okay, couple roof, which the rafter is supported by ridge board. Okay, we have a ridge. Where is the ridge? So please refer back to the previous slide. The ridge on top of the pitch of each roof, okay, and then connected and supported on wall plates. Where is the wall plates? So please refer to the diagram previously. So this one is suitable for the span not exceeding 3 meters, right? The next one is couple closed roof, have tie or ceiling joist. This one, okay, on the both rafter, we have some tie or ceiling joist that connected to both rafter. This rafter has been held by a ceiling joist. So this one is not exceeding 4.0 meter span. Okay, so you can refer to page 268 in the textbook. And then we have another one is collar roof, may be used for span up to 5 meters. Each pair of rafter is framed up with a horizontal collar, okay, which should be placed higher than one half of the vertical heights from wall plates to the ridge. Okay, this one you have to identify from the wall plate to the top of pitch of the roof, which is until the ridge. So this rafter should not be lower than one half. Okay, we should put it higher, okay, that nearest to the ridge, because we want to provide some additional headroom. Okay, so meaning that this uh, roof, inside the roof, there will be some extra space, okay, in that roof. And then we have double roof. When the span exceeds 5 meters, single roofs are no longer suitable as they use would entail excessively large and uneconomical timbers. So if the roof will be constructed more than 5 meters, okay, so we have to use double roof. In this roof, double or purlin roof are used at about 3 meters centers to give intermediate supports to rafter. So this one, they are going to put on another extra components to support the rafter, which is purlin. Okay, purlin is connected or all the rafter about 3 meters centers. Okay, the purlin supports the roof and are held out by struts that rest on load-bearing wall or ceiling beams. To make the roof stronger for bigger distances, hangers are added to every fourth rafter, which attach to the purlin and the ceiling binder. The ceiling binder is then nailed to the ceiling joists. The size of ceiling joists, binder, rafters, and purlins for pitch roof depends on the weight they need to support, the strength of the timbers, and the distance between them. So these are the components when we have to build in the double roof, which is to provide some more stable and stronger roof structures. So there will be hangers added every fourth rafters, and then there will be purlins, ceiling binders. Okay, so this size of ceiling joist, binder, and rafter, it says that will depends on the weight they need to support, and also strength of timber, and also distance between each of the ceiling joists and rafters, and so on. So these are the diagrams of the structures. We know that this is the ridge board. Okay, this is a wall plate. I see that previously when we want uh, to provide some additional extra room inside this roof, so how we going to put the ridge collar is on the top here in order to provide some extra room. So this one you can see, this is the purlin. Purlin is all the way connected with the rafter. We put rafter, okay, and then this is purlin. So this is hanger. Every four rafter we put one hanger. Every four rafter we put one hanger. Okay, and then this is struts that support the purlin. This is joist. Okay, so you have to recognize and remember all these components. Pitch roof types, trusses or frame roof. A trusses or frame roof is used for a large span over 7.5 meters and provide extra support to the purlins through roof trusses. And we have king and queen post timber trusses are used, which consists of large timber member bolted together at joints. The king post truss is a triangular frame that supports the ridge and purlins, which in turn carry the common rafters and roof coverings. So this is the difference between king post and queen post roof truss. Okay, so from the diagram you can see this is all the same, tie beam or ceiling joist. Okay, and then brick infill, so it has bricks infill here, and this is the purlin, yeah, the small square component here is a purlin, and then underneath the purlin it also have purlin clad. Okay, And then it has, this king post has two rafters. One is the principal rafter, and then it has another common rafter. Okay, so this is the same ridge board. So we have this one, king post, in the middle of the roof. Okay, this is a strut that connected with the king post. Okay, and then queen post, it has two posts, one, two here. Okay, two posts. Okay, which connected with the also has purlin and purlin clad common rafter. Okay, this one common rafter, it has wall plate, and also principal rafter inside. And the strut is connected to the purlin and purlin clad. So these are the overall components of pitch roof. Okay, this one also you have to remember how to sketch and remember every label of these components. So at this side is the verge side. Okay, and then the top one is ridge board. Okay, and then we cover that ridge board with the ridge tiles later on. This is the coverings. Okay, inside here is the things that we put all parallel. Here is the rafter. Okay, valley is the internal angle of a roof, so we call it as a valley. This overall here we put outside on top of the structure is the roof covering, provide resistance to penetrations of elements and convey surface water to gutter at eaves. So this is the eaves fascia. Okay, normally there is a rainwater downpipe here. What else? Purlin is connected with the rafter. Okay, and then you can see more details on page 265 to 275 on roof members. Okay, this is the video. Please watch the video from the e-learning that I have uploaded. This is how to construct each type of the roof form.
What's going on, guys? Today we're going to go over 5 different common roof types. First we have the gable, then we have the hip, we have the gambrel, the mansard, and the flat roof. Alright, so before we get into the roof framing, let's just quickly refresh on what's under the roof. So first we have the footings and then the foundation walls. And then on top of the foundation wall, we have the termite shield. And this stops termites from coming up to the wood structure. And here's a professional demonstration on how a termite shield works. Then we have the sill plate, which is fastened down to the foundation with the anchor bolts. Those are those metal pins that you see going around the whole foundation. Then we have the floor joists that sit on top of the sill plate. Then we have the subfloor. Then we have the sole plate and the wall studs. And then on top of the wall studs is the top plate. Then we have the ceiling joists that sit on top of the top plate. Alright, so first let's look into the gable roof. So the gable is probably the simplest one we're going to look at. It starts with 2 posts at the end walls. Then a ridge is placed at the specified height, and then roof rafters are cut to perfectly fit from the top plate all the way to the ridge. Then the fascia board caps off all the ends of the rafters. And when you have a gable like this, you end up with 2 attic walls, and these need to be studded. And the distance from the top plate to the ridge will tell you how big of a roof rafter you actually need. Obviously, the longer the span, the bigger the roof rafter. And this is the same thing with ceiling joists as well. And then you can see how the ceiling joists are connected to the side of the rafters. Okay, so looking at a gable roof plan, you can see that there's a ridge running right down the middle, and the roof rafters run from left to right from the ridge, and all the water is pitching away from the ridge because the ridge is the highest point in the roof. The whole point of a roof in the first place is to shed all of the water off of the roof and not to have any spots where water can puddle and sit. So this little notch in the rafter is called the bird's mouth, and this is the part of the rafter that's going to come in contact with the top plate and also be fastened to the top plate. And the bird's mouth gives the rafter a bearing point to hit the top plate, and then all of this weight is transferred down into the wall and then eventually into the footings. Alright, so now let's look at the hip roof. So this is a little bit more complex, but not really. So the posts, instead of starting at the ends, they start more in the middle. Then the ridge is placed, and then these hip beams from all four corners connect to the end of the ridge. And then we have all these rafters that fill in these four separate bays. And then the fascia board caps off all the ends of the rafters again. Okay, so looking at the hip roof plan, you can see there's a ridge running right down the middle, but unlike the gable, it doesn't extend all the way to the exterior walls. These four hip beams then connect to the end of the ridge, and the roof rafters run away from the highest point in the roof, as well as the pitch. Okay, so again, looking at the section detail for a hip roof, it's very similar to a gable. The only difference is that when the ceiling joists are running the opposite way from the roof rafters, there's something called a strong back, which is attached from the ceiling joist to the rafter. And this happens in this situation here where the ceiling joists are running the opposite way from the roof rafters. This is just to secure the ceiling system to the roof system. This makes everything much stronger. Here you can see on this side that the ceiling joists can be easily connected to the rafters and there's no issue. Okay, so next up is the gambrel roof, commonly referred to as the barn style roof. So this roof is a little bit more complex than the last two. So there's a few different ways to structure a gambrel roof. You can actually have full trusses that don't even require these walls at all, or you can have a beam that sort of sits in the middle of the two different roof pitches that I'm about to show you, or you could do this. So this one starts with a sole plate that's inset on only two sides. The other two sides, it goes all the way to the end walls. So basically what we did up here was we built another box. It has the sole plate, the wall studs, and the top plate again. So here we have the two posts that sit at the end. And then we have the ridge. And the first set of roof rafters will connect from the ridge to the top plate on the second floor here. So an easy way to think about this is that there's a separate gable on top of this sort of box here. And here are the rafters that make up that second steeper pitch on the side. A gambrel really has two roof pitches. There's one at the top and then one on the sides. The one on top is fairly shallow, and then the one on the sides is much more steeply pitched. And this gives that barn look. And just like the gable roof, we need attic wall studs here. So the gambrel roof plan is much like the gable roof plan. The only difference is that it has those two steeper pitches on the side. So we have the ridge that runs down the middle, and this goes from wall to wall. And the roof rafters come away from that ridge, and so does the pitch. And in this section, we can see how this all comes together. Alright, so next up is the mansard roof. Alright, so the mansard roof is very much like the gambrel roof. But instead of only offsetting two sides, we're actually going to offset all four sides, and we're left with this interior box here. It has the sole plate, the wall studs, and the top plate again. And this ridge doesn't span from exterior wall to exterior wall, it actually sits in the middle. Then we have four total hip beams which come from the corners of this box, and they go to the end of the ridge on each side. Then we have rafters that fill in these four bays. So remember how the gambrel had a gable on top? So an easy way to think of a mansard roof is that you're building a hip roof that's offset in from the exterior walls from the first floor. So the mansard has a secondary set of hip beams, and this comes from the corners of that box that we built on top, all the way down to the corners of the first floor. Then everything in between the hip beams are filled with rafters, and the fascia board is there to cap off all of the rafters. So the mansard roof plan is very similar to the hip roof plan. The only difference is that the mansard has these offsets off of every side, and that's that steeper pitch that comes off each end. So we have the ridge in the middle, it doesn't quite go to each exterior wall, and in a mansard roof we have 8 hip beams, not 4. And then the roof rafters run from the highest point, and so does the pitch. The section detail for the mansard roof is very much like the gambrel roof, but remember the strong backs in the hip roof that attach from the roof rafters to the ceiling joists? The same idea runs here, because there's going to be a point where the rafters do not run the same way as the ceiling joists, and that's where the strong backs are implemented. Alright, so next up is the flat roof with a parapet. So in the case of the flat roof, these actually aren't ceiling joists, these are called roof rafters, because this is the actual roof. Then the base of the parapet is laid out, and something called sleepers are laid on top of the roof rafters. And what a sleeper is basically a wedge of wood. It's kind of like that block of wood that you put in your door as a door stopper, to give you an image. Alright, so after that the parapet can be framed. A common pitch of a sleeper is 1/4 inch per foot, and this provides just enough slope so that water can shed off. So there's actually no such thing as a completely flat roof, because water needs to come off the roof somehow. You can't have water just sitting on top of your house. Not a good idea. So usually the water pitches into a drain. So you can see here in this illustration that from left to right there's the main pitch where the sleepers are going. But those two darker pieces pointing towards the drain as well, those are called crickets, and this makes sure that water doesn't pool up in the corner and sit there. So for the flat roof, there's a parapet going around the entire exterior. Then the sleepers are placed on top of the roof rafters, and this gives the roof a pitch. Then we have the two crickets on the top and the bottom, and these all pitch into that roof drain right in the middle to the right. And here's the section on how everything comes together. And understanding different roof types is really important because this distinguishes one style from another. You know, a shingle style house has a bunch of gables. You can have large sweeping gables. You can have very tall steep gables that go from the first floor to the third floor. Gables are commonly used in English Tudor design. Or you can have a massive gable that takes up 60 feet. Or you can have super pointy gables. Biltmore has a hip roof. You know, an Italian Renaissance style home has hip roofs. Roofs have different pitches when they're in different styles. And you'll notice that French design uses very steep hip roofs. Your hip roof can be very wide and spread out, or it can be very steep and tall. And then you realize, oh, the gambrel roof was created because there needed to be more attic space or a bigger second story, and the gable couldn't provide that headroom. So the gambrel provides that headroom. And then you see the mansard roof and you think Second Empire or French design. The Palace of Versailles has a mansard roof. And then you have the flat roof that just says, screw it, I don't want to see anything. Alright, so those are very simple examples, right? But once you start to understand how things go together, it can help you become a better designer, and it'll actually help you realize why things are designed the way they are. And knowing how things go together, it gives you a certain amount of confidence when you're in the design process, really knowing this is going to work. So yeah, I hope that helped, and I'll see you in the next one. Peace.
Okay. So this is what that I have mentioned before about lean-to roof, copper roof, and closed copper roof. So read the content that I have previously shown you. So try to relate to this diagram. Okay, copper roof, only wall, and then only a rafter, a pair or rafter here. And then we have closed copper roof. So this is a wall, rafter, and we have only the wall plate. Okay, sorry, wall plate. The collar tie that fixed to side of the rafter. So this can be expanded to 4.8 maximum. And then we have another one is the collar at in the middle of the rafter. Okay. And this is the types of double roof pitch. Double roof pitch, for example, we have this one is wall, and then internal load-bearing wall here. This is another wall, and then this is the ceiling joist. Okay, so we have struts, hanger, and then there's a collar tie to the rafter. Okay. So this one can be expanded more than 7, okay, 7 meters, okay, more than 7 meters, I guess. Gable or mansard roof. Gable roof have two pitch and breaks in the slopes. So based on the videos that you have watched before, we know that gable and also mansard have two pitch that breaks in the slope. The angle above the break is more than 45 degrees and while the angle below is greater. So we have two kinds of slopes. One is more narrow and one is more greater, okay, degrees. This will provide more headrooms in the attics and also includes dormer and roof lights. So gable roof come in different forms of construction. So this is the diagram of gable or mansard. Okay, we have ridge board. This is the collar that connects the one of the rafter we have, and then we have another high pitch rafter here that's connected with this stud framing. The below part is the ceiling tiles or floor joist. So this is a diagram of the mansard or gable. Now, flat roof. Why flat roof is normally constructed for commercial buildings, for example, shopping malls. So this one is something you have to ponder. Why? Why flat roof? We normally see flat roof constructed for commercial buildings. If you go to any shopping malls, most of the shopping malls has flat roof. Okay, so ask this to yourself. A flat roof may be the only practicable form of roof for many large buildings or those of complicated shapes and can be more economical propositions than a pitch roof. So you can refer notes about flat roof in details from page 290 to 294. So basically, we see that flat roof is the most economical roof that we can construct, and it is practical form for a large buildings. So every buildings that have very big sizes is suitable to have flat roof. Okay, this is the flat roof. Four different joists on the flat roof. Okay, we have number one, joist cut to fall. Okay, I guess up to this point you have already known what is joist. Okay, this is a joist. Normally this is the wall and then connected with this joist. So we have this joist is cut a slightly slope on top of it to form some fall. Okay, for the rainwater to go down. And then we put on some decking that fixed to the joist. Below is the flat surface, but on top of it have some slope that we cut. So simple to fix, but could be wasteful in terms of timber unless two joists are cut from one piece of timber. So it says that this is very simple, the simple methods, okay, but it is a wasteful of timber. Okay, the next one is joist laid to falls. So we have this joist, and then how we put the joist is slightly higher from one side from the other side. Okay, we cut the joist at the same sizes, but when we laid this joist from one wall to the other side of the wall is slightly higher. Because of what? Everything, the objective of this is to provide some falls for the rainwater. Okay. This is economic and simple, but sloping soffits may not be acceptable, but this could be hidden by a flat suspended ceiling. So we have to put some extra material from one end here just to provide some sloping soffit. Okay, next one is fairings with joist run. So we have this. We put this joist on top of each wall. Okay, the same size. We cut this joist, and then we have another extra components here. We call it fairings. Fairings. We cut this fairing. Okay, with some slope here, right, to provide fall. So this in the middle component here between this decking and the soffit is the fairing. Simple and effective, but does not provide a means of natural cross ventilation. Usual methods employ. So if we put this one, we cannot provide some natural ventilation. Okay, another method is fairing against joist run. So this is this one view, the other one side of the view, and then we go to the other sides of the view. Okay, just now we look from here or from here. Now we look from in front. Okay, so the fairings is put against the joist, against this joist. Okay, this is a joist, this one joist. Put it against. It is simple and effective, but use more timber than tree, but provide a means of natural cross ventilation. If you do it like this, so it is more simple, effective, and also provide some natural cross ventilation. Okay, so this is some example of the diagram. So you can see this is the example of fairing that we put, okay, in between of the roof joist or ceiling joist and the roof deck here. So inside here, this is a fairing. So another question is, why flat roof widely used in the Middle East? So this is another question for you to ask yourself and try to get the answer throughout this today's topic. Okay, this is another different example of flat roof. Sorry, flat for a roof types. So this is a green roof. This is a Nanyang Technological University, NTU. The key features of the uh, building design is the green roof that slope almost at 45-degree angle. So this is a very innovative kind of roof, which is a green roof. So if you have these opportunities to visit Nanyang Technological University at the Singapore, so don't miss out to see the in person how this roof look like. Now we go next to roof insulation. What is roof insulation? Why we need roof insulation? So this is the cross sections, the component details, components of roof. Before we put on the coverings of roof, okay, first we have to construct the structures of the roof. After we construct the structure of the roof, we have to put the roof insulation. After that, we cover the roof by roof tiles or materials that provide for the roof covering. So this is the top of the ridge top. So we can see that one of the example of roof insulation is the breather membranes with polyester coated aluminium flashing over the roof tile. So we lay these membranes to cover up all the ridge, top of the ridge, okay, before we cover with this ridge top. So inside of the roof, we should provide some ventilation, okay, inside of the roof. like this. This is the insulations inside the roof. So make sure that the air can pass through inside the roof. This is how the air is moving inside the roof. Airflow, airflow, sorry, airflow, flow from outside, go to the inside, and will go out from this opening. We have lower vent at each end of the attics. Okay, if you notice that both end of the roof, sometimes it has some openings there. Okay, from side to side, you can see if there are any openings, normally like lower vent or small patterns openings, and that is to provide the ventilations of the roof here. Okay, so with the some insulations on the roof, we could be provide some cooler environment inside the roof rather than hot when this sun absorb the heat from the roof and transfer inside the building. So this is one of the example. This is the one and cheapest example of the roof insulations. And sometimes we do not have this extra material here, this foam, only um, aluminium to cover the roof. That is um, um, already adequate, okay, to provide some insulations inside the roof. Next, we go for roof coverings and tiling. Roof coverings can be defined as the finishes to roof structure which cover the inner building from rain, sun, wind, and snow. Covering to any roof structure must have good durability to meet these conditions. So please have some further readings on page 278. So roof covering, basically after we finish all the structures, you put the insulations to make sure everything's the ventilation inside the roof is suitable and adequate. So we have to cover the roof. So why we need to cover the roof? It's to provide coverage, okay, from the rain, sun, and wind, and so on. So, and also it is a finishes. It also called as the roof finishes. This is the types of roof coverings. Okay, how we lay all these tiles, okay, on top of the roof structures. Another roof coverings. Okay, this is the shape of roof tiles. We have this one, ridge tile. We know that top of the roof have a ridge. So this is a ridge tile that cover the ridge part. And then this one must cover at the joints of each of the slope, right? Slope of the roof. And this is the standard size of when we lay these tiles on top of the rafters. Okay, and you have to know that roof tiles is uh, roof tile has a very many types. Okay, depends on the manufacturers, types, shapes, materials, and of course cost. So it has a lot of type. Like you are choosing finishes, right? Like you're choosing like floor finishes, uh, tile or cement or marbles. So it is same goes to roof covering. It has a lot of different types of coverings, shapes, cost, depends on what you require. So this is how we lay the roof coverings. Okay, put on this one is the timber batten, the size of timber batten, just to to interlock, okay, to to hang this every pieces of this on top of the rafter here. So we put this one a timber batten, so to hang these every pieces, and then this piece will interlock with the next piece. So this is the example more diagram for the roof coverings. So you know this is ridge, and then we cover this ridge. Okay, this is the feel of the roof. Okay, and this will also have a skylights or dormer window. So this is the batten, right, batten that we put just to hang every piece of this roof covering. So look here, right? Next is dormer window. A dormer is the framework of vertical window constructed from a roof slope. It may be used as a feature, but it is more likely as economical and practical means for accessing light and ventilations to a roof. Dormers are normally in external with the options of a flat or pitch roof. So this one is dormer window that we constructed on roof. So you can read further on page 304. So this is the example of dormer window on top of the roof. This is the detailed diagrams of how we create the opening, okay, on top of the roof just to provide this dormer window. And you have to remember this every components here. So this is the corner post, cheek post, and then trimming rafter. So we have to trim this rafter just to provide some hole here. Okay, trim this rafter. This one is rafter, right? Rafter, and then we have to trim this rafter to provide some hollow and to raise up this post. Okay, and then put on another rafter on top of it. Next is rainwater downpipes, which is known as WDP, RWDP. It provides to convey rainwater from roof gutters to underground drains. So when the rainwaters fall from the roof, go to the gutters, and then go down to the underground by drainage. So again, these materials is the normal materials, but you will see many kinds of materials from different manufacturers out there. For example, like cast iron, spigot, asbestos, PVC, prestress steel, aluminium downpipe. So there is a more material used to provide to construct this RWDP. Okay, this is one of the example. Okay, this is gutter. We call it the pieces that collects the water, rainwater here. We call it gutter. So this one is the gutter. This is gutter, and then this is the groundwater downpipe or drainage. So the water will go to the gutter, go to the rainwater downpipe, and go down here another gutter, and then will be channeled to underground. So this is one example of the components of the RWDP. So we have gutter that collects the water, and then this is the drain pipe line. Okay, another diagram of the gutter and RWDP. Okay, this one. The final one is the topic of this is timber roof preservation. So we know that when we use timber as the trusses, roof trusses, every timber has to be preserved from the woodworm that infest the untreated structure timber. So structures, it's very important. It is very crucial if we use trusses timber trusses. So therefore, we have to provide to get the timbers that are treated for wood worms or preserved timber. So these are the example of the wood worms. Okay, and then finally, this is just some of the pictures of the roof that you can see around the campus. Alright, so the next part will be continue as the long span roof, which is tension roof, cable suspended structures, cable supported or cable stayed structures, air supported or pneumatic roof, and then grid structures, folder flat roof, and shear roof. Alright, thank you for now.